Hi everyone. Today we'll talk about a classic system design problem, a URL shortener. This is going to be a simple system design. It's not too complicated. Let's first go through the functional requirements. So we should be able to generate unique short URLs, and the length of the short URL should have only a few characters. The short URL should contain only numbers and alphabets, that is 0 to 9, A to Z in caps or small, and should be able to create say 100 million short URLs in a day. These are the functional requirements. Moving on to the non-functional requirements, we should be able to handle high traffic. We can assume say 10x of the write traffic that we have, and it should be highly available and consistent. Now, the key part here with this particular question is on whether we are asking the right questions to narrow down the problem. So most of these mentioned here requirements are based on or inferred from the questions that will be asked. So please make sure that you ask the right questions to get to narrow down to the correct requirement. Right? Moving on to the numbers. So we have 100 million short URLs created in a day, that is around 1k write requests per second, and 10x of 1k is 10k read requests, and it should have only 62 characters. That's okay. And assuming 7 characters per short URL and 10 years of storage needed, we will have around 365 billion records, and the total data for short URLs will be around 2.8 TB of short URLs, and for the long URL, because we'll have a hash map of short URL to long URL, or however we want to store, but in general you can say it is a hash map. So it will be around 365 TB of data, right? So it is a lot of data that we need to store. Now, how does a short URL work? So HTTP has this redirect status code 301 and 302, which indicates that for a particular URL, when it hits the server can indicate to the browser that the URL does not exist or the URL is moved to a new URL. Our HTTP provides two different codes. One is 301 and the other is 302. 301 indicates that the URL has been permanently moved to the new URL, and 302 indicates that it is temporarily moved to the new URL. Now, when do we use 301? 301 basically what it does is it indicates to the browser, the client's browser, that the URL is permanently moved. So the next request to the short URL will be redirected to the permanent URL itself, because the browser will store the data in its cache, and if it finds the data in its cache, it will send it to the URL, the redirected URL, right? But in case of 302, the browser does not uh, get the data from its cache. It continues to send the request to the backend server, and the backend server will provide a redirect URL, and the browser will then redirect it to the redirect URL. The advantage of having a 302 is that it will be useful in analytics. So companies that implement short URL products, they make money through analytics and user actions. The 302 HTTP code helps in that, to get a lot of user data for analytics and share that user data to say data brokers uh, to make monetary benefits. So 302 is very important from that aspect for analytics. Moving on to the API endpoint. So we'll have two APIs. One is a post request and the other is a get request. A post request is basically to shorten a long URL. It will provide the long URL and it should return the short URL. And when the long URL is provided, it should validate that there are no collisions and the short URL is unique. And for a get short URL, it will basically provide a redirect URL for the short URL provided, and it should also validate that it is a correct URL. It is possible that the user might provide an invalid request, so it should provide the correct error response in that case, right? So there are two ways of generating a short URL. One is to generate a hash and then get the 7 character string if we want to limit it to 7 characters or how many ever characters we want. The other is to generate an ID and then get a base 62 value. Generating an ID and then getting a base 62 value will not essentially make it limited to 7 character string, because the ID can be long and it can be the base 62 value can differ based on the generated ID, right? But we can work around it if needed. And then moving on to generating hash method. So we can either use MD5, CRC32 or SHA1 to generate a hash, and from the hash we can either take the first 7 characters or any set of 7 characters from the hash and check if that short URL is in the database. If it is there in the database, then we'll have to loop again and generate another hash and then check again. We'll be doing this until there is no collision. And what we could also do is add a salt string to the URL and try to generate the hash. Now generating ID, we can use a distributed ID generator to generate unique IDs. The advantage of this is that it ensures that there are no collisions, but the drawback will be that the length of the short URL can be small or long. And then once the ID is generated, we'll get the base 62 of the ID generated to get a unique short URL. Moving on to the design, it is fairly simple. There's nothing fancy here. We'll have an API gateway which will get the request. We can have multiple tiny URL services, distributed services, and the API gateway can have a load balancer which will actually send the request based on the load to a particular tiny URL service. The tiny URL service in turn can generate and store the short URL and the long URL mapping in MySQL DB, and the MySQL DB should be configured to store say 365 TB of data as per our calculations. And we can also have cache to have a smaller set of data for quicker retrieval of the recently used short URLs. And if it is not there in the cache, they can always get it from the MySQL DB. So this is all for the short URL system design. The key aspects here would be more on how the short URL is generated based on the data provided, and if we have made sure that all the requirements are satisfied based on the questions. That's all for today. Thank you everyone.